Alright, this is your help video for quiz 4.03. The first question says, what is the area of a rectangle with vertices at these four places? Alright, you don't technically have to graph it, but I am very visual, so I graph everything. I have some graph paper, some scratch paper on my desk, and I use it all the time. So for me, I'm going to go ahead and graph this. -3, -1, 1, 3, 3, 1, and -1, -3. Again, graphing isn't a requirement, but I think it's really helpful. Okay, so now that we have our rectangle, we know that the area of a rectangle is base times height. And it doesn't matter which one we let be the base and which one we let be the height. The only thing that matters is the height has to be perpendicular to the base, but in a rectangle, all the angles are 90 degrees. So I'm going to go ahead and let this side here be the base, and I'm going to let this side be the height. Alright, and unfortunately those don't follow the grid, so we can't just count the units to figure out the length. We either have to do Pythagorean theorem or the distance formula. Alright, I'm going to go ahead and show you the distance formula on this example, and we'll do Pythagorean theorem on another one. Okay, so I'm going to find the height first. So I'm going to use the ordered pairs right here at -1, -3. That's going to be my first ordered pair. And then my other ordered pair is at 3, 1. So I'm going to let that be my second ordered pair. Oops, that's supposed to say y2, not xy. Alright, and when you label your ordered pairs for the distance formula, the first ordered pair is just x1 and y1, and the second one is just x2 and y2. And then we're going to plug it in. And remember, the distance formula says x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. So if I plug all that in, my x2 is 3. My x1 is -1. Notice I put the minus sign there and the -1. You need both signs. My y2 is 1. And my y1 is -3. So again, I need the minus and the negative sign. We need both of those. And then from here, you can do some mental math, or you can type it in the calculator. I'm going to show you what it looks like to type it in. Okay, so this is my favorite calculator of all times, and you can use it on the end of course test. So it's a really great handheld calculator to own. It's only $18 or $16, I can't remember, at Walmart. So this is a great calculator. And the reason it's so great is because you can type it in one step. So I'm going to type in the square root of 3 minus -1, close my parentheses and square it, plus 1 minus -3, close my parentheses and square it, and then I'm going to hit enter. And that tells me the exact answer for the distance is 4√2. I'm not going to round it yet. I'm going to leave it as 4 square root of 2. Now, if you use your computer calculator, it's going to go ahead and round it for you, and that might cause you a little bit of rounding errors, but hopefully you can still use some reasoning to get the right answer. Okay, so then for the base, we need to use the ordered pairs. So -3, -1, I'm going to let that be x1 and y1. And then -1, -3, that's over here. I'm going to let that be x2 and y2. And then I'm just going to plug it into the distance formula. And it does not matter which ordered pair you let be x1 and y1 and x2 and y2. It really doesn't matter. Alright, so -2 minus x2 minus x1 squared plus y2 minus y1 squared. So again, we're going to type that in our calculator. Okay, and after all that clicking, that distance is 2 square roots of 2. And then to find the answer, remember the answer didn't say find the distance of each side. The answer said what is the area of the rectangle. So we would have to multiply the base times the height. So 2 root 2 times 4 root 2. So I'm going to multiply those two things together. And again, I'm going to do it in this calculator. So 2 square root of 2. And you can either use the times button or parentheses. They both mean the same thing. So times 4 square root of 2. And that gives me a final answer of 16. So the area is 16 units squared. All right, so this one says, what is the perimeter of a rectangle? All right, so for perimeter, we have to add up all the sides, which means to start off, we need to find each of the side lengths. I don't even know why this little box is down here. That's not correct. Okay, so we need to find each of these side lengths. This time I'm going to show you how to use Pythagorean theorem versus the distance formula, because you might like that method better. So for Pythagorean theorem, if I want to find the distance of this side, I need to draw a right triangle. So I'm going to follow the grid lines, and I'm going to go straight down and straight over and draw that right triangle. And then I'm going to count each side, because now it follows the grid perfectly. And then I can plug it into the Pythagorean theorem. Now the whole theorem says a squared plus b squared equals c squared. And so you could plug it in just like this. 3 squared is 9, 9 plus 9 is 18, and then you could square root it. So that distance right now is just the square root of 18. But there's also a little bit of a shortcut. If we know that we're solving for c, up in the original equation, we can just isolate c by taking the square root of each side. And so every time you write it, you can just write it as the square root of a squared plus b squared and type that straight into your calculator, and you can get the answer that way. So let me show you what I mean by that on this next one. Let's take that little shortcut. If we want to find the side length of this blue line, the first thing we have to do is we have to create a right triangle. So we're going to follow the grid, and then we're going to count the units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see, that's 4 and 5. That's also 9. All right, so for that one, I'm just going to plug it into the shortcut formula. So 9 squared plus 9 squared. And then I'm going to pull up my calculator, and I'm going to type it in exactly like that. The square root of 9 squared plus 9 squared. Oops. And that one is 9 square roots of 2. And I'm not rounding it yet. I'm going to leave it exactly like that. And the cool thing about a rectangle is once you know this side is 9 square roots of 2, we know the opposite side also has to be 9 square roots of 2. And if we know that the red side is the square root of 18, we know the other side also has to be the square root of 18. So that's a pretty awesome shortcut as well. And then to find the perimeter, we would just add all of those together. So let me change colors here. We would add the square root of 18 plus the square root of 18 plus 9 root 2 plus 9 root 2. And I'm just going to go and type that into my calculator. Oops. I have to get out of my radical. There we go. Okay, and so this calculator tells us the exact answer, 24 root 2. But it also tells you the decimal approximation if you hit the double arrow right above the enter sign. So I'm going to hit that double arrow, and that approximately is 33.9. So we could go up here and we could say our answer is 33.9 units. The other really awesome thing that you can do, if you get to a test and you're like, I have forgotten, well, we'll get to that later. Let's keep going. Okay. This one says, what is the area of the triangle with those vertices? So again, you don't have to graph it, but I love graphing everything. So I am going to go ahead and graph it. especially when it's triangles, because the height is a little bit more difficult to figure out than when you have a rectangle. Because here's the thing with height. Height has to be perpendicular to the base. So you can let any side you want be the base. I'm going to let this side be the base. And the reason for that is because it follows the grid. So I can just count the units. 1, 2, 3, 4. So I know my base is 4 units. But if that's my base, the height has to be perpendicular. And right now, neither of those sides are perpendicular. So I have to draw in the height. That's why it's really important to me that I graph it. Otherwise, sometimes I mess that up. So I'm going to start here and I'm going to go perpendicular all the way up to the top. So that is a 90-degree angle, and I had to go all the way up to the top. So my height, I'm going to count that as actually 1, 2, 3 units. And then I'm just going to plug it into my formula for area of a triangle, which is 1/2 of the base times the height. 4 times 3 is 12. Half of 12 is 6. So the area is 6 units squared. Okay, for this one it says, what is the perimeter of the triangle? So for perimeter, you have to add up all the sides. Unfortunately, none of these, oh, this one does follow the grid. So yay, we can just count this one. Makes me really happy when they follow the grid because that makes it nice and easy. For the other two sides, you either have to use the distance formula or Pythagorean theorem. Does not matter which way you choose. I'm kind of a fan of the Pythagorean theorem, so I'm going to go ahead and do that. So if I was going to plug this into the Pythagorean theorem, I'm going to do the square root of 6 squared plus 6 squared. And I'm just going to type it in. So that's 6 root 2. So this distance here is 6 root 2. And then I'm going to go and I'm going to either use the distance formula or the Pythagorean theorem for the other side. Again, I'm just going to use Pythagorean theorem. I'm a pretty big fan of it. So I'm going to plug that into the Pythagorean theorem. This one I could probably do in my head, right? 6 squared is 36. 1 squared is 1, so this is the square root of 37. And then we just want to add all 3 of those sides up to get the perimeter. So 6 root 2 plus the square root of 37 plus 7. So let's go to our calculator and do that. 6 root 2, forgot what it was, plus the square root of 37 plus, I forgot to get out of my square root. Now we did. Okay. Okay, so this one tells us it's about 21.56, which if you round would be 21.6 units. All right, and then the last one, we need to go ahead and plot these vertices. Okay, and mine ran off the graph a little bit, but that's no big deal. And then to find the perimeter, we have to add up all the side lengths. So we need to start figuring out our side lengths. The ones that follow the grid, you can just count. That's 7 units. 2, 4, 6, 7, 8 units. And then this one's also 7 units. The ones that don't follow the grid, you have to either use the distance formula or the Pythagorean theorem. I'll go ahead and do distance formula this time since I did Pythagorean theorem the last time. This point is at 3, 9, so that's going to be my x1, y1. And this point is at, let's see, 7, 12, so that's going to be my x2, y2. And then I'm going to plug it into my distance formula. x2 minus x1 squared plus y2 minus y1 squared. And I'll type that in. Okay, so I found the distance of both of these, and both of these are 5 units. And so then I would just add 5 plus 5 plus 7 plus 7 plus 8 to get the perimeter. So in this case, the perimeter is 32 units. All right, good luck on your quiz.